Welcome back to Parametrics Part 2. So the next three examples, we're actually going to end up with the standard form of one of the conics that we've been working with. So we're going to use some strategies like we did in number 4, and also some trig identities, and some information about exponent properties to get these three standard forms of a conic. So if we take a look at the first one, we're going to square both sides, but if I square both sides right now, I'm not going to end up with something that's easily identifiable as a conic, and also it's still not going to be easy to eliminate the parameter theta. So before I square both sides, I want to get the cosine and the sine by themselves. So my first equation here, I'm going to put x minus h, so I'm subtracting the h, and then I'm going to divide by the r, is equal to cosine of theta. Now that I have that, I'm going to square both sides. So now I have the quantity of x minus h squared over r squared equals cosine squared of theta. Similarly, with the second equation, I am going to square both sides after I isolate the sine. So here I have y minus k, over, I'll just put parentheses around that now, over r is equal to the sine of theta. And now I'm going to square both sides, so y minus k, quantity squared, over r squared is equal to sine squared of theta. So now we're going to take these two and we're going to add them together. So if I add the left side here with the left side here, so I'm just going to put a little note, add equations together. So now on the left side, what I have is the quantity of x minus h squared over r squared is equal to, plus the quantity y minus k squared over r squared is equal to, and then we have cosine squared plus sine squared, which, you guessed it, equals 1. I can look at this now and I notice my denominators are both the same and I'm adding in the equation. So here we want to put it into the standard form for one of the conics. Which conic do you see? Hopefully you're thinking a circle. So we have x minus h quantity squared plus y minus k quantity squared is equal to r squared. Therefore, this is a circle. Cool. Number 7. So now we're going to do the same thing. So let's go ahead and isolate the trig pieces of this. So on the equation on the left, I'm going to subtract h, divide by a. So I have x minus h over a is equal to secant of theta. And then on the right, so it's a little bit different, I have y minus k divided by b is equal to tangent of theta. So now I want to think of a trig identity that involves secant and tangents. And if you're thinking about your Pythagorean identities, we're going to use I can get a tan in a second. Perfect. Now, the left equation is equal to secant, so if I square that left equation, what I have is the quantity of x minus h squared over a squared equals secant squared of theta. On the right, I'm going to square and I get y minus k quantity squared over b squared is equal to tangent squared of theta. Now, I have a tangent squared equation and a secant squared equation. So if I look at my identity that I have right here, I want to think about what would I need to do with that tangent and that secant squareds to be able to eliminate. Well, I would want to figure out what would make them equal to 1. So here, if I subtract tangent squared, 1 is equal to secant squared of theta minus tangent squared of theta. So now what I'm going to do, instead of adding, I am going to subtract the equations so that I have secant squared minus tangent squared. So I'm going to do the red equation minus the green equation. So in the red equation I have this. That's my first piece. So what I'm going to have now is x minus h quantity squared over a squared minus the left side here, y minus k quantity squared over b squared, and then is equal to, and we would have secant squared minus tangent squared. Secant squared minus tangent squared equals 1. and I look at that equation, this now is the standard form for the equation of, you're right, a hyperbola. And to go one step further, this hyperbola, is it vertical or is it horizontal? Since the a squared is underneath the x term, which is the positive, that's our first term, our hyperbola is going to be horizontal. And there we have our solution. One more for this second section. Now we have exponentials. This looks kind of funky. There are a couple different ways that you can do this. One of the ways that we can do it is we can also square both sides. But some might look at this and say, well, if I add them together, I could eliminate this and this. But if I do that, then I'm going to end up with x plus y equals 4 to the negative t plus 4 to the negative t, which still doesn't eliminate my parameter. So that's not really going to be that helpful. So instead, let's go ahead and square both sides. So square both sides again. So on the left, I have x squared is equal to, oh, now I have this whole quantity of 4 to the negative t plus 4 to the t, quantity squared. So I need to expand that. So I know when I expand that, I'm going to have the first term squared. So if I have 4 to the negative t squared, I multiply those exponents, so it's 4 to the negative 2t. I'm going to have the second term squared, so 4 to the positive 2t. And then I have plus 2 times the product of those two terms, 4 to the negative t times 4 to the positive t. Okay, let's simplify this a little bit. X squared is equal to 4 to the negative 2t plus 4 to the 2t. Here, when I have these two, 4 to the negative t times 4 to the t, they have the same base, so I'm going to take the exponents and add them. So negative t plus t makes 0. 4 to the 0 is 1. So that's just plus 2 times 1, which is just 2. So I temporarily have that equation for my x. Now I'm going to do the same thing with my y. So with my y equation now, let's see here. Y squared is going to equal, and again, 4 to the negative t minus 4 to the t quantity squared. So expanding that, I again have 4 to the negative 2t plus 4 to the positive 2t, and then I'm going to again have, no, this case minus 2 times 4 to the negative t times 4 to the t, which the negative t and the t make 4 to the 0. So I simply have y equals 4 to the negative 2t plus 4 to the 2t minus 2. Now I'm going to take these two equations and I'm going to add them together. So my x equation here and my y equation here. So putting these two together, and we're going to add. So let's add the, whoops, I noticed I forgot my squared on my y right here. Y squared, y squared. So adding those two equations together, on the left side I simply have x squared plus a y squared equals, on the right, 4 to the negative 2t. Maybe I shouldn't add them together. How about we subtract them instead? Because I notice 4 to the negative 2t is the exact same as the 4 to the negative 2t. So let's switch that. Let's subtract. So it's x squared minus y squared equals then 4 to the negative 2t and 4 to the negative 2t will cancel. So cancel, cancel. Similarly, I have 4 to the 2t minus 4 to the 2t. Those two will cancel. And then I have a 2 minus a negative 2 is going to give me plus 4. So now I have x squared minus y squared equals 4. Well, this has a subtraction in it here. Since its subtraction is going to be a hyperbola. So let's go ahead and divide by that 4. So x squared over 4 minus y squared divided by 4 is equal to 1. So therefore, we have a hyperbola And again, the x is the positive term, so it is also horizontal. And that is the end of today's lesson. You can look at the assignment list for your homework and then submit your homework via your Teams app under the assignments. Please email me if you have questions and let me know on specific ones which you have questions, and we'll be looking into setting up a meeting to be able to discuss your questions. That's all for now.